so in this lesson, or this part of lesson 1, we're going to be modeling polynomials. So in algebra, we use algebra tiles. You have to be able to add and subtract polynomials, both pictorially, so using pictures, and the way that we do that is by using algebra tiles. And we have to do it symbolically, so just doing the math. One thing I do want to know, or want to tell you, is that in your textbook, the textbook always has yellow as positive and red as negative. However, that's not going to be the case on your PAT. You really have to watch your legend. When we print, we're going to print in black and we're going to print in white. You have to be able to identify which one's positive and which one's negative. Okay? So the legend tells you, you have to read the legend to make sure that you know which one's negative and which one's positive, because they will switch it on you. Okay? So you have dealt with this in grade 7. Here they're saying that the shaded ones are positive 1 and the unshaded is negative 1. You've also dealt with these, the variable tiles, in grade 7. However, now we have a negative variable tile. So we have a positive variable tile, which you saw in grade 7, and now you have a negative variable tile. That could have been taught in grade 8, I'm not quite sure. But in grade 9, this is new. Okay? So now this dimension is x times 1, right? So this length right here, if that's x, that means that this is x. And this is x. Okay, so if I want to find the area of this, I go x times x, and that's where I get x squared from. Okay, so actually these are the areas of these tiles. This has a dimension of 1 by 1, so that is why this area is positive 1. This has an area of 1, because if I take this tile and put it along here, it would be the same. And since I don't know what that one is, I'm going to call it x. And 1 times x is x. Okay, so that's kind of the background about what algebra tiles are. Well, algebra tiles get their name from the area. So I forgot I had this slide, so I kind of explained it. So length times width is equal to the area. So here, since these dimensions are 1 by 1, that's why it's called the unit tile. We have an area of 1 unit, because 1 times 1 is 1. This is an x tile because, like I said, if I take that tile and I put it right here, this length right here would equal to that length right there. They would match. They match perfectly. So 1 times x is actually equal to x. So that is why it's called the variable tile. And same thing here. If I was to take this dimension right here, or this length, and then match it up to here, it's going to be the exact same thing. So that's why this is dimensions x, and it's a square. We know it's a square. So that must be x. So x times x, I don't like that. It looks like too many x's, so I'll do that instead. So x times x is equal to x squared, and that's why this is called the x squared tile. So that's the background behind it. So we're going to use tiles to represent the following polynomials. So let's do unshaded tiles to represent negative, and shaded tiles to be positive. Okay? So here we have 3x squared. So that's shading. So we have an x squared, an x squared, because we have 3 of them. We have to make sure they're shaded or positive. And we have 3 of them. So this is 3x squared. 2 x's is unshaded because they're negative. Negative 2x. We have to make sure that we draw our rectangles about the same dimensions. And then plus 5. So I'm going to just do my plus 5 and do the best you can to make them squares. They're not going to be perfect. So, and they're shaded. Okay. So that's how we would represent 3x squared minus 2x and plus 5. Okay, so x squared, same legend, shaded, 3x. I'm going to draw my 3x's in, and they're shaded because they're positive. Okay, so I'm going to do the best I can here. And then minus 6, so we have to have unshaded for negative. We have to have 6 of them because we have 6 unit tiles. Okay, 1, 2, yeah. So here's my x squared, here's my 3x's, and here's my minus 6. So that's how I would pictorially show a picture of your polynomial. Now, just as a review from part 1 of our video, it's a trinomial because here's one term, here's another term, here's another term, and this is also a trinomial because it has 3 terms. So just a little review. So now I want you to do a quick check. Here, let shaded tiles represent negative and unshaded represent positive. So shaded this time is negative, unshaded is positive. So you can pause the video and try these and then press play again and check your answers since this is a quick check. So welcome back. So this time we have unshaded is positive and we have 5 A's. So we have 5 rectangles. And since unshaded is positive, we're not going to shade those ones. There's our 5. And then 3 negative unit tiles. And this time our unit tiles are negative, or shaded are negative. So we're going to shade those because it's minus 3. And again, remember back, we change all our subtraction statements to addition statements, and that's why this becomes negative. Here, this is positive, and unshaded is positive. Now make sure that these don't look like rectangles. Try make them to be as square as much as you can. Like I have to be able to identify the difference between these two. I have a minus b, and if it's minus, I'm going to shade it because shaded is negative, and I have plus 4. And they stay unshaded. Okay? And again, if you're not too sure, write all your subtraction statements as addition statements, and then it'll be very clear of which tile you need to use. Okay, so here it says let the unshaded represent negative and the shaded represent positive, and they're all shaded, so it should all be positive. So let's match. 2x squared plus 3 matches that one. We have 2x squareds and we have plus 3. 3x plus 2, well, we have 3 variable tiles, 1, 2, 3, and 2 unit tiles. And 2x plus 3 has to be that one because we have 2 variable tiles and 3 unit tiles. Okay. So here's another quick check. Another way that I can ask this question is by writing the polynomial. I'm going to give you the picture and you give me the symbols. So here it says shaded is negative, unshaded is positive. You really have to be careful what the legend says. So shaded is negative. So I have a shaded x squared tile, so negative x squared. I have an unshaded, 2 unshaded variable tiles, so negative x squared plus 2x. Here we have 3 unshaded variable tiles, and unshaded is positive, and 1 shaded unit tile, so minus 1. Now if you wrote it like this, that's okay, but if it was a multiple choice, it would be written in simplified form, like they would write it with a subtraction sign instead of it as an addition sign. Here we have 2x squared tiles that are shaded, and shaded is negative. So negative 2x squared. We have 1, 2, 3, 4 shaded variable tiles, and shaded is negative. Negative 4x squared. Sorry, negative 4x, my apologies. And we have 3 unshaded unit tiles, and unshaded is positive, so plus 3. So equivalent polynomials are polynomials that have the exact same terms, but they're just in different order. Okay? So here, so therefore, if you were to do the algebra tiles would just be in a different, just mixed up. They're the exact same algebra tiles though. So if I have a 3x squared and a 3x squared and a 2x and a 2x and a -1 and a -1, just because they're in a different order, it is the exact same polynomial. However, if I have a -1 here, and look here, I have a +1, right away this is not equivalent, because this one would have a different tile than that one. It would look different. Same thing with this. This is a positive 3x squared. This one's a negative 3x squared. They're different tiles. So you really have to be careful to make sure that they are the exact same algebra tiles, just in a different order. Okay? So let's check that out. Oh, and then descending order. So polynomial always tend to be written in descending order, and that means that the exponent should decrease from left to right. So if you have this variable, since this has the biggest exponent, sorry, and it was negative, I tell you guys not to do that, and I do it myself. Ha ha ha. Sorry about that. So negative 4k squared comes first because it has the biggest exponent. And then your 2k, and then your constant term. Your constant term always comes last. Always, always. So polynomials will always be written in descending order. Okay? So let's rearrange the following polynomials in descending order. We have a 4p squared, and then a negative 2p, because this is 2p to the 1. So we have a p squared, a p1, and then our constant term comes last. Because really, it's p to the 0, remember? So same thing here, 5x squared minus 8x plus 7. So these two are equivalent polynomials. These two are equivalent. They're the exact same polynomial, just written in a different order. Okay? Descending order will be the one that you see in your distractors. In multiple choice tests, they'll always be written in descending order, and also in your textbooks, they'll always be written in descending order. So 100c squared plus 90c, and then plus 33. Okay, so c squared, c1, and then c0. Okay? So in an algebraic expression, a polynomial is an algebraic expression that contains one term or a sum of terms. Exponents of the variables have to be whole numbers. The numerical coefficient of the terms of b and xy is 1. Remember that. That's usually tested. There are special names depending on the number of terms. So remember, a monomial has 1 term, a binomial has 2, and a trinomial has 3. The degree of the term is the sum. You have to add up all those exponents of each individual term. And then the degree of the polynomial, take the highest number. So you're going to look at each term separately and then take the highest number, and that'll be the degree of the polynomial. So you guys have some work to do. Okay, so turn 214, 250. So there's a few questions there. Make sure you check your answers. If you're going for an 80% or higher in my course, you must do that question. Otherwise, you're just not exposed to that level of questioning. Now, this is something new. And I can tell if you complete it or not. Okay, so this is a check-in. It's a Google form. you must be in your GSacred account. So if you go to this form and it says that you need permission, get out of your Gmail account, log into your GSacred account, and then type in this. It is extremely case sensitive. So if you type one letter, if you put it as a baby X instead of a capital X, it will not connect you. Okay, let me know if you have any issues with accessing this URL. And it will take you to like a little online test. I think there's 2 questions. I just want to check in and see if you're doing it right. But these questions are to be done first. Okay, so I hope this lesson was good, and I will see you guys tomorrow.